Anthropic's 10 trillion parameter Claude Mythos sparks a global security debate. OpenAI pivots to AI coworkers for enterprise, and Google and Marvel partner for custom AI silicon. If you are trying to navigate this incredible paradigm shift and stay ahead of the curve, you already know things move fast. Welcome to inuku.com, AI news you can use, your daily dose of AI know-how. Let us dive straight into a massive enterprise shift happening today, April 20th, 2026. If you're still thinking about AI as a helpful little chat window where you type a prompt and get a paragraph back, you are living in the past. The era of the chatbot is officially over. That was basically the training wheels phase. What we are witnessing right now is a rapid, aggressive transition from AI as a tool that you use to AI as a totally autonomous department member. Imagine an employee who literally never sleeps. They work 24 hours a day, 7 days a week. While you are just having your morning coffee, this employee is autonomously running a Fortune 500 company's global marketing strategy, discovering a cure for a rare genetic disease, and hacking into a sovereign nation's secure financial grid, all in under 10 seconds. That is not a sci-fi pitch. That employee is literally clocking in today. The foundational infrastructure of human productivity is rewiring itself right in front of us. Speaking of aggressive transitions, we have to look at the ruthless strategy pivot coming out of OpenAI. They are pivoting their entire operational model toward these enterprise AI coworkers, and it has triggered a massive talent shuffle. We are seeing really high-profile departures. Kevin Weil is leaving the Science Initiative, Bill Peebles is exiting the Sora video project, and Srinivas Narayanan is stepping away from his enterprise leadership role. They are deliberately shedding all these massive, culturally dominant consumer projects, the stuff that actually goes viral. They are cutting the side quests to focus obsessively on high-value Fortune 500 integration. You have to look at the underlying metrics to understand why they are doing it. It all anchors to a new professional work benchmark called GDP-Val. GDP-Val is a rigorous multimodal evaluation of high-level cognitive labor, and OpenAI's internal models just hit an 83% human parity score on it. 83% human parity is a staggering number. When your model can perform 83% of complex multi-step corporate tasks at a human level, the economics just completely flip. You stop wasting millions of dollars in compute power generating hyper-realistic videos of dogs riding skateboards, and you take that massive intelligence and embed it directly into the back end of corporate software to handle the heavy lifting, financial modeling, rigorous legal drafting, and global project management. They are cutting the side quests because the main quest is infinitely more lucrative. It is a transition from generative content to generative action. We are seeing this exact same thing with Adobe and their new agentic marketing system. It is no longer a creative director asking a machine to generate a cool image for a campaign. The system is taking the reins of the campaign itself. It is a true agentic workflow. For anyone who only knows standard prompted response AI, think of an agentic workflow as the difference between a really high-end calculator and a senior accountant. In a standard system, you prompt the AI, it does the math, spits out the text, and then it goes completely dormant. It literally waits for you to tell it what to do next. It has no initiative. But an agentic workflow means the AI possesses the autonomy to navigate multiple separate software environments. It executes an action, evaluates the outcome, realizes if it made a mistake, and then course corrects, with zero human prompting required. You give it a high-level goal, and it figures out the micro steps to get there. Let me ground this in a real-world scenario to show you the sheer scale of this. Think about a massive commercial airline. Say the FAA suddenly grounds a specific model of aircraft at 2 a.m. due to a mechanical issue. That is a total logistical nightmare. In an old workflow, an AI might just draft an apology email to the passengers, a basic text generation task. But in a true agentic workflow, this digital coworker actually realizes the grounding happened by actively monitoring FAA weather and data APIs natively. Then it autonomously accesses the ticketing database, identifies all 50,000 affected passengers, pings global hotel APIs, negotiates block rates for stranded passengers in real time, issues the vouchers to their phones, rebooks them, and updates the flight crew manifests, all while the human executives are literally asleep. It strings together a massive web of disparate APIs to solve a dynamic problem. That is exactly what Adobe is launching for autonomous campaign management. These agents launch campaigns across 50 platforms, monitor real-time conversion data, and tweak color palettes and demographic targeting on the fly, minute by minute. But there is a philosophical pushback happening in boardrooms right now. If we are handing over multi-million-dollar operational logistics to agentic systems just to boost profit margins, aren't we automating away human intuition? Are we automating away the bold, weird leaps of logic that great managers make just for the sake of frictionless, infinite mediocrity? The inherent trade-off for infinite scale is almost always homogenization. When an agent optimizes purely for the lowest cost routing or engagement metrics, it naturally strips out risks. It strips out the soul, basically. But the economic reality is brutal. Companies that refuse to adopt these systems to preserve human intuition will simply be outcompeted on margins and speed. Period. Market forces dictate that the efficiency gains drastically outweigh the qualitative loss, which is terrifying when you think about where else this is being applied. We are seeing this exact paradigm shift hit the life sciences with explosive force. OpenAI just launched GPT-Rosalind, deliberately named after Rosalind Franklin, the chemist who helped visualize the physical structure of biology. GPT-Rosalind allows us to natively compute it. Historically, the drug discovery pipeline is an agonizing 10 to 15-year process of trial and error with massive failure rates. But by introducing a native biological agent like Rosalind, you are effectively turning organic chemistry into a computable search problem. You are mathematically proving a reaction in a digital simulation before you ever step foot in a lab. Look at the capital flowing into this space. Boehringer Ingelheim just dropped £150 million into a massive AI research center in London for this exact purpose. The entire pharmaceutical industry understands this is an existential pivot. But the deployment strategy for GPT-Rosalind is totally locked down. You cannot just pay $20 a month for an API key. It is restricted via a trusted access program to partners like Amgen, Moderna, Thermo Fisher Scientific, and the Allen Institute. Why the intense paranoia around an AI that just wants to cure diseases? Because of the terrifying dual-use nature of the technology. When you build an AI that natively understands how proteins fold and how molecules bind to receptors, you are inherently building a biological weapon. The exact same mathematical weights used to engineer a cure for a rare disease can trivially be inverted to engineer a novel pathogen. Let us look at what that means in practice. Imagine a team of environmental scientists tasking a highly specialized biological AI to design a synthetic bacterium to aggressively hunt down and consume microplastics in the ocean. An ecological miracle, right? But that exact same biological architecture in the hands of a bad actor could be prompted to mutate those binding properties. Instead of eating floating plastic bottles, it is optimized to rapidly consume the specific silicone insulation wrapping the transoceanic fiber optic cables on the seafloor, blinding global internet communications in weeks. The AI does not know the difference between saving the ocean and destroying the internet. It just solves the protein folding puzzle. That friction between the desperate need for speed in medicine and the catastrophic risk of biological weaponization is why the guardrails have to be so tight. You cannot uninvent the knowledge once it is out there. Which leads us directly into the shadows of the cybersecurity world today. If you thought the biology models were guarded, the fallout from the Anthropic leak makes the biology guardrails look like an open-source hobby project. Anthropic has confirmed the existence of Claude Mythos, and it is a genuine watershed moment. We are talking about a 10 trillion parameter model. To put that in perspective, the models that completely changed the world 2 years ago were a fraction of that size. And Mythos is not optimized for writing poetry. It is optimized relentlessly for cybersecurity and autonomous coding. It does not just check for bugs, it can autonomously chain software exploits. Exploit chaining is the difference between a burglar finding an unlocked window and a highly coordinated syndicate pulling off a multi-stage bank heist. Mythos finds a weak spot, writes a custom script to break through, establishes a foothold, scans the internal network, and keeps burrowing deeper until it has root-level system control autonomously. The detail causing actual panic is its proficiency at identifying zero-day vulnerabilities. Think about building an impenetrable fortress with 100-foot concrete walls and laser grids. But completely by accident, the quarry that supplied the stone for your main gate used a limestone that dissolves instantly when exposed to a specific type of tree sap. A zero-day means you, the creator, are completely unaware this fatal flaw exists. You have had 0 days to patch it. When an attacker finds the sap, they melt the gate and walk in. Now imagine a 10 trillion parameter AI simulating millions of interactions a second, actively looking for that sap across every piece of enterprise software on Earth. Mythos is basically a skeleton key factory. It has reportedly found thousands of these 0 days in ubiquitous operating systems, which is why Anthropic is withholding it entirely, restricting it to entities like the NSA. They desperately need to stress test our sensitive infrastructure before an adversary builds a similar model. But all this hyper-optimized hardware is not just inflating stock prices. Highly efficient systems are bleeding directly out of the data center and into physical reality. Google DeepMind just launched Gemini 3.1, and the specs are insane. It hit a 94.3% score on the GPQA Diamond benchmark, which is a PhD-level reasoning evaluation across physics, biology, and chemistry. It proves the model is doing rigorous logical deduction. But the real breakthrough is its 10-hour video context capability, driven by its native multimodal architecture. In the past, if you showed an AI an image, it used a vision program to translate the pixels into text, and then the language model thought about the text, a clunky process introducing latency. Native multimodal abandons that. It processes sight, sound, and text simultaneously in a single unified cognitive stream. Zero latency reflexes. Imagine feeding an AI an entire 10-hour drone footage feed of a massive skyscraper construction site. The AI is not just summarizing the video, it natively cross-references the footage with architectural blueprints in real time to instantly flag a structural load-bearing error on the 44th floor. That synthesis of high-level reasoning and massive unstructured data is incredible, and it is why Apple is integrating Gemini into a completely reimagined Siri via private cloud compute, evolving it into a cross-app, context-aware agent. The most visceral example of this physical edge is the humanoid robot in China that just shattered the human half-marathon record. Running 13.1 miles at 15.6 miles per hour in 50 minutes requires biological-grade balance. It achieved that using native multimodal vision and real-time reinforcement learning, actively seeing the terrain and adjusting for gravel natively. The gap between cloud intelligence and physical dexterity is closed. But are we building the ultimate personal assistant or the ultimate inescapable surveillance enforcer? The exact same vision system that helps a robot navigate disaster rubble to save a child can be deployed to track and pursue individuals in a dissident crowd with zero latency. The tech is agnostic to morality, and our legal frameworks are light years behind. Which leads us to the trust crisis. When an AI can mimic speech instantly, write zero-day exploits, and outrun us in a marathon, the fabric of trust unravels. The solutions feel dystopian. Look at the massive upgrade to the World ID protocol. Biometric iris scanning orbs for proof of humanity. They are rolling out deepface technology for Zoom, integrating with DocuSign to ensure verified human-signed documents, and launching AgentKit for Vercel, BrowserBase, and Exa to distinguish bots from human agents. It is becoming mandatory global infrastructure. Think about a high-stakes online poker platform requiring an iris scan to ensure you are not playing against a probability engine, or a remote telemedicine portal using facial depth scanning to guarantee the surgeon advising you is not a deepfake scammer. The baseline assumption is now that you are synthetic until proven otherwise. Let's play out a chained zero-day attack from an agentic AI in the physical world. Imagine a smart grid electric vehicle charging networks spanning North America. Mythos does not try a brute force password attack. It finds a zero-day flaw in the digital handshake protocol that happens when a specific EV connects to a charger. It chains that exploit to gain access to the charging company's cloud server, burrows into the regional power substations, and orchestrates a massive voltage spike across 2 million cars at the exact same millisecond, completely blowing out the electrical grid and destroying the batteries of the fleet. Human analysts would not even receive the alert before the grid goes dark. You cannot have humans manually patching firewalls against an intelligence operating at the speed of light. That is why financial regulators in Asia and European banks are holding emergency sessions. They are actively panicking. How can international financial regulators govern a digital asset that lives on a server but attacks with the combined intellect of 1,000 nation-state hackers? Traditional regulation assumes you can inspect the asset and audit the code. When the asset is a black box neural network, that fails. These frontier models are transitioning from commercial products to highly classified national security weapons. It is less like regulating Microsoft and more like the early days of nuclear governance. The only actual defense against an AI operating at the level of Mythos is an equally powerful defensive AI, which just accelerates the arms race. But there is a physical ceiling to this arms race. Running 10 trillion parameter models requires a staggering amount of physical compute. The infrastructure of our world is buckling under the weight. We are looking at an $800 billion global capital expenditure on AI. Energy demand is becoming a massive geopolitical and profit bottleneck, and the hardware itself has to evolve. Morgan Stanley just predicted a massive CPU and memory boom driven entirely by agentic AI. For the last 5 years, NVIDIA and their GPUs have held an absolute monopoly. But the nature of the workload is changing. When you train a model from scratch, you need GPUs to crunch massive data sets. But once it is trained and you have autonomous agents reasoning through problems and navigating APIs over days or weeks, that requires incredible memory bandwidth and CPU performance. The compute moat is shifting from raw training power to inference efficiency. That is exactly why Google is in late-stage talks with Marvell Technology to build custom AI silicon, specifically memory processing units and TPU variants. They are desperate to cut their reliance on NVIDIA. A big part of winning that efficiency war is Google's recent breakthrough with their KV cache compression algorithm, reducing memory needs by 6 times. Let us unlock what a KV cache, or key value cache, actually is. Think of it as the AI's short-term working memory during a specific conversation. Without it, the AI would have to start from scratch and reread the entire chat history every single time you asked a follow-up. Imagine hiring a brilliant Michelin star chef to cook a 10-course menu, but the chef has no prep station and 0 short-term memory. Every time they need a pinch of salt, they have to walk 3 miles to the grocery store, find the salt, bring it back, add it, and instantly forget where the salt is. The energy cost would be astronomical. The KV cache is basically giving the chef a massive prep station right in front of them. But as these agentic workflows span over hours or days, that short-term memory bloats massively. By compressing that KV cache by 6 times, Google is saying you can now run long-running workflows on vastly cheaper, less power-hungry hardware. It addresses the memory wall bottleneck for scaling AI agents directly. And to tie all these disparate agents and memory banks together, we have the Model Context Protocol, or MCP, which just hit 97 million installs. Think of MCP as the new universal USB port for AI. Before USB, every piece of hardware had a proprietary plug, a fragmented nightmare. Enterprise AI has been dealing with that exact same fragmentation. An OpenAI agent could not easily pull data from a legacy Oracle database or a custom Anthropic model. MCP is a standardized open-source bridge allowing entirely different AI models to plug into the same enterprise databases seamlessly. It is the connective tissue of the agent economy. But what makes this moment in tech history so fascinating is watching the corporate hype cycle attach itself to this very real infrastructure overhaul. It is reaching absurd levels. Look at Allbirds, the company that makes those comfortable wool shoes. They literally just sold off their entire shoe business to pivot to Newbird AI, styling themselves as a GPU as a service company. And the market rewarded them. Their stock went up more than 600% on the announcement. It perfectly encapsulates the manic phase of a tech revolution. It is pure speculative absurdity, like a 1990s pet food catalog slapping a .com on their name, or a mattress company in 2021 rebranding as a Web3 protocol. Institutional investors know the underlying $800 billion shift is real. They just do not know who the winners are yet, so they throw money at the word compute. That inversion of trust is also reshaping how information is published. We have the rise of utility news because AI search engines like Perplexity and Google AI overviews have killed traditional web traffic. Publishers are abandoning clickbait and optimizing purely to be cited by the AI models. You are writing for machines, not humans, which inevitably leads to what Peter Steinberger, the founder of OpenAI, calls work slop. Because compute is cheap and agents are autonomous, we are generating massive piles of identical, thoughtless digital garbage. It lacks soul, and we saw this backfire spectacularly with Anthropic's Claude Design, powered by Opus 4.7. On paper, it was a massive flex, a natural language design tool that exports to Canva and PowerPoint. Figma's stock tanked on the announcement, and their chief product officer resigned. But the user backlash over the actual output has been intense. Users are calling it container soup because Opus 4.7 was trained with rigidly constrained default aesthetics. Imagine trying to generate a bespoke financial restructuring presentation for a legacy logistics firm, and Claude spits out the exact same teal-accented generic interface it gives to a teenager designing a skateboard app. Functionally flawless, but aesthetically bankrupt. Plus, it has severe hallucination issues. People are calling it Gaslightus 4.7 because it confidently defends its own errors. This highlights Andrej Karpathy's point about AI psychosis, or token maxing. Developers are getting a dopamine hit from the sheer volume of output, maximizing raw tokens with zero regard for quality, confusing velocity with value. We use AI to generate websites, AI search engines to read those websites, agentic workflows to design presentations based on the summaries, and we use iris scanners just to prove a human was in the room. At what point does the human become a bottleneck in an entirely machine-to-machine internet? Before we get into the final takeaways, just a reminder that you can find more insights like this at inuku.com. To summarize today's massive shifts, the transition to autonomous agentic workflows is tearing through the enterprise sector, fundamentally changing how corporate software, marketing, and even biological research operate. With models like OpenAI's internal GPT reaching 83% human parity on the GDP-Val benchmark and Claude Mythos chaining zero-day exploits, AI is no longer just generating text. It is generating complex, sovereign actions. This incredible surge in capabilities is causing a brutal $800 billion strain on hardware infrastructure, shifting the focus from GPU training to CPU and memory inference efficiency, as seen in Google's KV cache compression and Marvel partnership. Finally, as physical humanoid robots set athletic records and AI handles multi-step coding and design natively, the crisis of trust is forcing humanity to adopt biometric verification like World ID just to prove we are real in a sea of synthetic work slop. And that's your daily dose of AI know-how from inuku.com. AI news you can use.